Hey everybody. So in this video, we're going to be talking about simplifying radicals or simplifying square roots, to be more specific. So it'll be a really short video, so I hope you guys pay attention and find it pretty easy because, in my opinion, it actually is. So all we're focusing on today is simplifying square roots or simplifying radicals. So by definition, and I put the definition right below, this is for every single math class that you're ever going to be into, so you might want to write this down. So radicals, a radical is basically a number in the form of n, a little number on the outside with a square root, and then m on the inside. So that means the nth root of the number m. The number on the outside represents the root of the number on the inside. A number like this, which is 2 root m, this is called the square root because there is a number 2 on the outside. So that one is called the square root. A number with a 3 on the outside would be called the cubic root because there's a number 3 on the outside. And then a little 4 on the outside would be called the fourth root, etc., etc. You can have a fifth root, sixth root, seventh root, eighth root, all the way to infinity. So specifically today, we're going to be talking about simplifying square roots, meaning that we're going to be talking about when you have a 2 on the outside of that radical. Now, they are called square roots because of the 2, right? Perfect square. They're the most common in mathematics. But since they are the most common, we omit. The word omit means to leave it out. We omit the number on the outside and just assume that it's there. Kind of like when you guys have like x, that's the same thing as 1 multiplied times x, right? There's a 1 in front, but we don't really write it. Same thing here. We omit the 2 on the outside. We know it's there, but we don't really write it when we talk about square roots. Square roots should actually be 2 root m. In this case, if they write just the square root of m, that's the exact same thing. There's a 2 there, but you can't really see it. Now, that being said, I mentioned a table to you guys in the past. This is the list of all square roots that you should already have memorized, so you should already know this. So the square root of 1, square root of 4, square root of 9, square root of 16, all the way through the number 15. These are all perfect squares. Why do you need to know this? Because every now and then you have something that's a perfect square, and it saves you a lot of time and effort if you know the table of square roots. So if you don't know it, you might want to jot these down real quick. Okay, so really simple steps. So like I said, it's going to be a short video. First thing you need to do to simplify a radical is first, step 1, you have to draw a factor tree. So factor tree means break up the number inside of the radical completely to the factors as what times what gives you that number, right? So for example, 2 times 3 would give you 6. So just break it down as far as you can completely. So number 2, you have to circle the ends of the factor tree. That's just something that I like to do so I know where the factor tree ends. Number 3, for every single pair, and I'm going to underline pair here, you're going to have to take that number on the outside of the radical. Why do I want a pair? Well, if you remember when we talked about square roots, there's a little 2 on the outside of every single one of these that we don't really write. So therefore, we're looking for pairs to be able to take that number on the outside. So this would actually be the same thing when you have a 3 on the outside, you want 3 of the same. If you have a 4 on the outside, you want 4 of the same number. If you have a 5 on the outside, you want 5 of the same number, etc. Step number 4 is the last one. At the very end of the problem, if there's anything left over on the inside or the outside, you just basically multiply it out. Okay, so it's very wordy, but it'll make sense once we start doing some problems. So example number 1, we're going to start really simple. So you want to simplify the radical completely by using a factor tree. That one's a perfect square, so you know the answer to that, right? The square root of 9 is equal to 3, so we know that answer is 3. However, we're going to do it using a factor tree. So if I do it using the steps, I would actually break this apart and say, okay, this is going to be the factor of 3 multiplied by 3. I cannot break this up anymore, so I'm going to circle it. So whatever I have as a pair, I'm going to take that number on the outside. So I'm going to go ahead and just cross these out and put it on the outside. So I know I have a 3 on the outside. Whatever's left on the inside, which in this case, there's nothing left on the inside, I'm going to be leaving alone or leaving it on the inside. In this case, when everything is gone, I'm going to put a number 1 inside. And then at the final step, it's basically you multiply everything together. The square root of 1 is 1, so we get 3 times 1, which is equal to 3. Now, this way is longer, However, you're going to get problems that are much more complicated to simplify, and it'll make your life way easier in the end. So the final answer for this one is 3. But like we said, we knew that already. Now let's try something that we haven't. It's not quite so obvious. So we want to take the radical 12, we want to simplify that. So I'm going to do that the exact same way. I'm going to break this up into factors. So what number times what number gives me that number right there. So one of the factors, or two of the factors that I can break up into, is 6 times 2. 6 times 2 is 12. I can't break up the 20 more, so I'm just going to leave it alone. The 1 doesn't change anything, so you can't really change it from a 2. If I break up the 6 again, I can do that by 3 times 2. And then I can't break anything else further down without me getting the same number, so I'm basically done. So now, do I have any pairs, right? 2 of the same number. So I have 2 of the same number here, 2 and a 2, so that number goes on the outside of the radical. And then the only thing that's left on the inside of the radical is that 3. So my final answer becomes 2 radical 3. 2 on the outside, and then the 3 stays on the inside because it didn't have a little buddy to go out with. Poor 3. All right, example number 3. That's it. So moving right along. Example number 3, I want to simplify the radical completely by using a factor tree. So notice for this one, example 3 and 4, we have numbers on the outside. So we're going to talk about what do we do when we have numbers on the outside? And the answer is just forget about them. Just leave them there. Don't worry about it. We're going to go back to it on example number 4, or sorry, step number 4. Step number 4 says at the very end of the problem, you just multiply everything together, whatever's on the inside or the outside. So it's basically just there. Just deal with it. So let's factor out the 128 first. So 128, I can simplify that out. I can factor it out as 64 times 4, right? 64 times, I'm sorry, not 4. 64 times 2 is 128. I cannot break the 2 anymore, so I'm going to leave that there. 64, where can I break this up into? There's a lot of different combinations. If you did 8 times 8 is 64, then that is correct. And you would be able to get to the final answer already, right? Because you already have a pair here. So that means that the 8 can go on the outside and the 2 stays on the inside. However, I'm going to pretend like I didn't choose that. I didn't choose 8 times 8. I chose something else. So I'm going to go ahead and use a different answer. So let's say I go 32 times 2 is 64. Doesn't matter the factors. It'll still give you the same answer in the end. 32, 8 times 4, right? And then 8 is 4 times 2. 4 is 2 times 2. I'm making this much more complicated than it has to be because just to show you guys that it works out either way. 4 is 2 times 2. And then everything is broken apart. I circled all my endpoints with the exception of that 32. That should not be circled because that is not the end of my factor tree. So sorry about that. So I'm only circling the ends of the factor tree, the stuff that I cannot break up anymore. So once I have that, now all I got to do is look for pairs. So go back to the circles and then just look for pairs that match up. So 2 and a 2, I can take that on the outside. 2 and a 2, I can take that on the outside as well. I'm going to put a little multiplication symbol. 2 and a 2 here, I can take that on the outside. And then this 2 doesn't have a buddy to go out with, so it just stays inside. So that 2 is going to stay on the inside, right over there. Now, at the beginning of the problem, I said, don't forget that you have a number on the outside. If it's on the outside, it's still there. So I'm going to go ahead and write that 3 that was on the outside initially. The last step says, whatever we have on the inside or the outside, we multiply it all together. Notice here when I multiply 2 times 2 times 2, I get 8. So it's basically the same thing that I would have gotten the first time if I would have just done it with the 8 times 8. So I'm going to be left with 3 times 8 here on the outside and then square root of 2 on the inside. When I multiply the two terms together, is 3 times 8, which is 24. And then finally, I get square root of 2 on the inside. So my final simplified radical is 24 square root of 2. So the whole purpose of this is trying to find pairs, 2 terms that are the same number. Once you have pairs, 2 that are the same number, you can go ahead and get those guys out. Okay? So I could have stopped at the 8. If I would have kept on going, it would have still gotten me the same answer. All right. Example number 4 is my last example for you guys. Let me zoom in just a little bit more, and then you will get your practice sheet. Or not. Yep. Let's just leave it there. So 7 square root of 45. Square root of 45, what can I break that up into? So I'm going to go ahead and do factor trees. 5 times 9 is 45. 5 I cannot break up anymore, so I'm going to go ahead and circle it. I can break up the 9 a little more, as in 3 times 3. And then after that, I can't break up the 3's anymore, so I'm basically done with that. Let's go ahead and look for pairs. Are there any 2 that are pairs? In this case, there are 2 3's that I can take on the outside. So I'm going to go ahead and put that on the outside. The only thing that's left on the inside is the 5, so I'm going to leave it as the square root of 5. Okay, now I would be done, but like I said in the beginning of the problem, there is a 7 on the outside, so it's still there. Whatever's left over at the end, we basically just have to multiply together. So my final answer is actually 7 times 3 radical 5, so it's actually 21 radical 5. Okay, so I hope this was simple enough. If you guys have any questions, let me know. Have a good one.